Hi, this is a video on the special segments in triangles, and there's 4 special segments we're going to talk about. Alright, the first one is called an angle bisector. An angle bisector is a ray, okay, that goes from one point and extends in one direction that bisects an angle. Remember, that means that it splits it in two evenly. Alright, so we're just going to do some practice. So if we're going to draw an angle bisector, we can pick any one of these angles we want. We're just going to do this one on the bottom left. So what you're going to do is you're going to go from the vertex of the triangle, and you're just going to go out until it meets the side opposite the vertex. And when you're done with that, what's going to happen is you're going to have two angles that are congruent. Now the cool thing is that if we were doing constructions, we could actually do a construction that would actually bisect that angle. Okay, so let's do this other one. Same thing, you're going to start from a vertex, and let's go ahead and go from the top. You're going to start from the vertex, and you're going to go down till it meets the opposite side, okay? And then what that does again is that it splits that angle that you're going to into two congruent angles. Okay, so an angle bisector is a ray that bisects an angle. Okay, so let's do a practice problem. Alright, so these markings right here tell you that that's an angle bisector. So all that means is that you can do 3x minus 8 is equal to 2x plus 3. Right, then we solve that, take away 2x from each side, we get x minus 8 equals 3. Then we're going to add 8, so we get x equals 11. Okay? All right. Okay, one more. So it says angle DKM equals 48. So that so if this angle right here is 48, and we're going to assume that that's an angle bisector because that's what we're talking about, that means that each one of those angles is going to be equal to 24 degrees, because if it's an angle bisector, it cuts it in half. So now all we're going to do is we're going to do x squared plus 10x equals 24, and we're going to set it up. Remember, if you have the square, it's a quadratic, so remember we're solving for two values. So x squared plus 10x minus 24 equals 0. Alright, so now we ask ourselves, what is multiplied together to give us 24 and added together to give us 10? And a factor of 24 that does that is 6 and 4. So we know one has to be positive, one has to be negative. And I take that back, it would actually be 12 and 2. So we would have x plus 12 and x minus 2. So when we set that equal to 0, you get x equals negative 12 or positive 2. Okay. Alright, so here's our next one, a median. Okay, a median is a line segment with endpoints at a vertex of a triangle and the midpoint of the side opposite the vertex. Okay, so this is different than an angle bisector. The angle bisector came from the vertex and extended to the side, but it split the angle in half. This is a little different in that you find the midpoint, let's say that's the midpoint of this side, okay? And from that point, it extends to the vertex. So it's not necessarily an angle bisector. It could be, but it's not necessarily. So you know that this is a median because it splits that side into two congruent parts. Okay, same thing with this other triangle. So if we say that this is the midpoint, you go from the vertex and you extend down, okay, and it creates two equal segments. Right? So there's no guarantee that these angles up here are split. Okay, let's do a couple problems. Alright, it says AC is 24, so that's this whole entire distance right here is 24. And AD which is this one right here, is 3 times x minus 5, and it wants us to solve for x. Okay, so remember, these markings right here tell you that these two are congruent, and since there's a line extending from the vertex to that side, you know that it's a median. Okay, so if the whole thing is 24, you know that each one is 12. So we can set it up to 12 equals 3 times x minus 5. Divide each side by 3, and we get 4 equals x minus 5. So that means that x is equal to 9. Alright, so here's the third one, the altitude. Okay, the altitude is basically just the height of the triangle. Okay, it is a segment from the vertex of the triangle to the line containing the opposite side and is perpendicular to that side. Okay, so in this first triangle up here, we could draw several altitudes. Let's just pick one. So altitude goes directly down and it creates a right angle. Okay, now when you're drawing an altitude, the one thing that has to be true is that it has to extend and go perpendicular to the side. It doesn't mean that it's an angle bisector, and it does not mean that it's a median. Okay, so let's take this obtuse triangle. So an altitude on an obtuse triangle, you're talking about the height of this triangle. You probably remember this from past stuff. If you extend this out, and then you go ahead and draw the height of the triangle, okay, that's the altitude of that triangle, because basically all you're doing is you're talking about the height. Now each of these triangles has 3 of these segments in them, 3 altitudes, 3 angle bisectors, 3 medians, but we're really only talking about one at this point. Alright, and this right triangle, okay, obviously we've got an altitude here, because it makes a right angle, and we also have another altitude right here, okay, but let's go ahead and draw this other one. So it's going to go 90 degrees from that vertex. So that would also be an altitude. So just remember, an altitude is talking about height, and just like when you do, area and volume of shapes, the height is the perpendicular distance from the base all the way to the very top. All right, now we talked about this one the other day, the perpendicular bisector. Okay, so perpendicular means that it's doing a right angle, and bisector means that it's splitting in half. So perpendicular bisector is a line that passes through the midpoint of a side and is perpendicular to that side. Okay? Now the cool thing about a perpendicular bisector is that it doesn't always have to be from a vertex of a triangle. Let's look at the triangle on the right. So if we're going to split this side in half, that's not in the middle. Okay, so if we're going to split this side in half, let's just say that's the middle right there. If you draw a perpendicular line up, you see how that doesn't go to any kind of a vertex? But it's still a perpendicular bisector because it's coming straight down, it makes a right angle, and it splits that side in half. Okay? So we could also do this other one. So let's say that this, that this is the midpoint. Right, so it's going to go perpendicular and split each side in half. Okay? So if you're doing this triangle here on the right, the perpendicular bisector, let's say if we go from here at the bottom of the base, if this is the midpoint, then it has to go straight down from up there. Okay, so you notice how it doesn't always extend from a vertex. So that is perpendicular, and we have 2 congruent segments. So just remember, the perpendicular bisector does not always come from the vertex. And I'm going to go ahead and draw another triangle just to kind of show you. Last week we talked about isosceles triangles. Right? So isosceles triangles are congruent on each side, and their perpendicular bisector, because that midpoint is directly over, it does extend from the vertex okay, and goes straight down. And it also creates two equal segments there, okay? So what we basically have is a right triangle, an obtuse triangle, and then an acute triangle. All right, so let's just do a couple problems here. This one is saying this is an altitude, so that means that this side is equal to that side. So it would be 4x plus 6 equals 5x plus 3. All right, we're going to move the 4x, so we get x plus 3 equals 6. We're going to move the 3 over, and we get x equals 3. Okay? All right, this one too, we've got a perpendicular bisector, so that means it is bisecting. These two are congruent. So now we have 2x squared equals 18. Okay, now I know I said that if you have a quadratic that you're going to set it equal to 0. Now if you don't have just an x term, right here you have an x squared, but if you don't have an x term, you want to see if you can go ahead and solve it. So in this case, we would divide each side by 2, because it only has one value. Well, it actually does have two values, but we'll talk about that in a second. So this goes away, so we get x squared equals 18 divided by 2 is 9. So if you're squaring something, the inverse of that is taking the square root. So the square root of x squared equals the square root of 9. Okay, the square root of x squared is x. And I don't know if you guys talked about this in algebra or not, but if you take the square root of a positive number, its answer is actually the positive and negative of it. So the x could be plus or minus 3, because negative 3 squared is 9, and positive 3 squared is 9. All right, so here's our last one, a midsegment. A midsegment is a segment with endpoints that are midpoints of the two sides of the triangle. So basically what it is, it's going to end up being a line. So here's our base down here. Okay, the midsegment is going to end up being a line. If I do the midpoint of this side and the midpoint of this side, it ends up being a line that is parallel, so it's parallel to this side, and then it creates congruent sides. So this side is congruent to this side, and this side is congruent to that side. Now the other thing that happens is that the midsegment is actually half the distance of the base. So if the length of the base was 4, then the length of the midsegment would be 2. Okay? So let's do this one. So there's our midsegment, creates congruent side there and congruent side there. And then remember that the midsegment is half the length of the base. So if this is 4, then the base has to be 8. Okay? All right, so these are all the notes that we have. Oh, hold on, we've got a problem here to solve, sorry. All right, so it says SR is 14. All right, and just by looking at this, we see we've got this line here, and because it created congruent segments on this side and congruent segments on that side, you can say that it is a midsegment. So if this one is 14, we know that the midsegment is half the distance or the length of the base. So if this is 14, this has to be 7. Okay, same thing. We know we've got congruent segments here, so we know it's a midsegment. It says that SR is 5x minus 2, and TJ is x plus 8. All right, so we know that half of SR is equal to TJ. So we could say 5x minus 2 divided by 2 is equal to x plus 8. All right, when I get here, I like to just put it over 1, and I treat it like a proportion. So I'm going to multiply, right, do my cross products. 5x minus 2 times 1 is just 5x minus 2. And then x plus 8 times 2 is 2x plus 16. So now I'm just going to go ahead and solve. So I get 3x equals 18. So x is congruent to 6. Then we can plug it in and see. So TJ over here is 6 plus 8, which is 14. And SR is 30 minus 2. Gets 30 minus 2, which is 28. So half of 28 is 14, so we know that we did that one correctly. All right, so those are all the notes that we have. Just make sure that you guys can recognize each one of those segments and what their properties are, okay? And you just go back and study your notes if you need that. All right, you guys have a good night.